So welcome to week 13. We're going to talk about some time series analysis information. We're coming out of regression equations and model building. So this is really a very logical next step to where we are going to go with this use of regression. We're going to see some other techniques, but it's all going to be built upon the ideas of regression that we've already studied. So last time I talked a lot about the elements of model building, which is actually what we're doing this week in class. So I'm actually getting a little bit ahead, which I think is good, because the whole time series analysis is something that you may not be as familiar with. It's not as intuitive, but it's something that in business statistics can be very, very useful because it's, again, about predicting the future, which of course is what regression is about, making predictions, and ways of making decisions about how the sales and the products that are being offered, how those are going to be acquired and perhaps displayed. So let me give you an example with that. Have you ever gone to Walmart and it is maybe late November, you walk into the store and right at the front of the store there are snow shovels and ice melt. And you've just recently heard that there's supposed to be some nasty weather moving in. How is it that they are able to have those products right at the front of the store at that very moment? Well, they're using time series analyses on a much higher level that we're going to be discussing, but that's what they're using. This ability to predict what is going to be required at certain times based upon, in this case, weather patterns, and they are able to move products around and have them available in certain stores so that when you walk in and you say, hey, I think I really do need a new snow shovel, they're able to provide that even before you knew that you needed it. Okay. So then what we're going to talk about is forecasting. So what is forecasting? We're looking at historical data about time series. When we talked about regression, we were measuring at one given point of time. So perhaps I do some kind of survey in which I'm gathering data at one single time point and I'm putting that into a regression equation. With forecasting, we're using time series data. So that means a set of observations over successive periods of time. This is like repeated measures. So we're gathering information at more than one time, and we're using that information to make our forecast or our prediction. So let's talk about some forecasting methods. There are qualitative and quantitative forecasting methods. Qualitative would be relying on an expert. We're going to find someone and this person is an expert in the field and we're going to ask them, what do you think is going to happen? Now, we're not going to talk about qualitative methodologies. We're going to focus on quantitative methodologies. Those have to do with numbers. That's where we're taking data and we're using techniques to analyze that data so that we can then use the predictions that we get from that to make decisions. So there are two basic areas of quantitative analysis that we're going to look at: time series and causal. So we can use either time series or causal methods. Time series methods use past values in the series that we're trying to forecast. So let's take previous data, analyze that data, make a prediction. Versus causal is where we use historical data, and we're using time series that might be related to the time series that we're trying to forecast. So with causal inferences, we are taking more than one predictor, more than one time series, and working that into our analysis. So let's dig down a little bit deeper with time series and causal. Time series. What you're trying to do with a time series analysis is discover a pattern. The data reveal the pattern. And then we extrapolate that pattern into the future. The past being the best predictor of future behavior. Now, in some cases that works exceptionally well, and in other cases it is more difficult to make those predictions. But we're going to look at past data and then extrapolate from what we have learned into the future so that we can make that prediction. Okay, so our forecast is based only on the past values of the variable that we're using to forecast. We're not using anything extraneous to that. We're just looking at sales trends and making a prediction of the future based upon that one variable. Causal methods are where we use a regression equation. We're making an assumption of a cause-effect relationship and using multiple variables in that regression equation to make the forecast. So if we get a good set of predictors, then we can develop this regression equation to forecast our time series. Causal inferences. Now you may say to yourself, isn't regression one of those correlation methods that we've learned about? And wasn't the most important thing we learned about correlation is correlation does not imply causation. So how can we use regression and causal methods? Well, here again, this is where that time series idea comes in. If I am gathering data at one point in time, if I am gathering data through a survey, and I'm asking you about your job satisfaction and your level of burnout and your intention to leave the organization, I'm asking you about all of those variables on a single survey at the same time. Because there is no space between, no time between the measurement of those variables, we should be very cautious about making any causal inferences to say that burnout causes low job satisfaction. Now here, with this type of analysis, the causal analysis that we're talking about, we have time series data. For cause and effect to be in place, the cause has to occur before the effect. And the only way we can ascertain that is if we have information being measured at different points in time. So because we have multiple time frames in which we're measuring, we can now start to make some more causal inferences. This tends to occur before that. And as a result, we can say that when we see this occurring, we can predict that that will follow. So we are able to make causal inferences when we have time series data, certainly in a way that we couldn't if we're using just the measurements at a single time. So now we're going to talk about time series patterns. We are going to measure in a sequence. Now that sequence could be, we're measuring every hour, or we can measure every day, or every week, or every month, or quarter, or year, or any other regular time interval. Our strategy is then going to be to, first of all, observe the pattern of the data. We're going to see how those data have behaved in the past. And then, if that past behavior can be expected to continue, we're going to use that as a guide in selecting what type of forecasting method that we will use. And so we're going to explore what are the forecasting methods that are available to us. The best way to make the decision about what type of analysis we're going to choose is to use or start with a time series plot. So the first thing that we should do is, rather than looking at tables full of data, is let's plot them. In this case, we'll use a line plot. Create the data points, connect them with a line, and that is going to begin to reveal the trend, the pattern in the data. And we could then describe those patterns or trends in a number of ways that will then allow us to decide which is the best strategy for us to use as we're doing our analysis. And I'll also mention, we always put time on the horizontal axis, and then the thing that we're measuring is going to go on the y-axis. Because as we're making predictions, we want to predict based on time to that thing that we are trying to predict. So here's an example of one of the patterns that we might discover. It's the simple horizontal pattern. Things go up, things go down. There's just always that fluctuation and moderation of data over time. What we could do with a simple horizontal pattern is simply draw a line through it. It's the mean. So here, we could take all of these data points, just get the average. So how much are we going to sell, or what will be the outcome at any given time? It's going to be somewhere near the average. And all of those fluctuations that we observe, those are just randomness at play. It's the particular setting on the machine at this moment in time. It's the humidity in the air as we're creating and manufacturing this certain part. There will be micro deviations from the average that we're shooting for. So in this pattern, this horizontal pattern, we could simply draw a straight line to represent where the trend lies. It's just a simple mean that becomes our best predictor. That's a horizontal pattern. Other times, we look at the data and we see there is a distinct trend to these data. We're looking at our sales figures and we're noticing that yes, there are ups and downs. There are those normal random fluctuations, but when we step back and look at the big picture, we see this upward trend. So we're seeing a gradual shift to higher values, or sometimes unfortunately we're seeing a gradual shift to lower values. Unfortunate if it's a sales situation. But we're seeing these gradual shifts that are occurring. These are usually due to long-term factors. So maybe our product is really catching on and we're seeing growth in the demand for this product. Or maybe there's changes in the population growing older, or demographic shifts that are occurring in the population, and that's changing the demand for this product. Or maybe new technology is being introduced, and that technology is replacing the technology that we have always used, and now we're seeing a downward trend pattern with our data. So we're looking at those overall big picture trends and using that to make our prediction. Another pattern that we might observe as we look at the data, that will help us choose which type of analysis we want to use, is the seasonal pattern. So let's say we are examining the sales of those snow shovels that I mentioned. Do you think that the sales of snow shovels are going to be constant over time? Of course not. We're going to see increases in the times when there's more snow, and we're going to see decreases in the middle of summer. And that pattern should repeat itself over and over every year. A seasonal pattern is the successive periods that occur within a year. So for us to use the seasonal pattern, the time frame in which we're studying must be less than 1 year. Now, the seasonal does not necessarily refer to our 4 seasons. Obviously, it was an easy example to use winter as the time when we sell more snow shovels, but it doesn't have to be according to the 4 seasons. It could be according to something else. Maybe something to do with the academic calendar and the sales of textbooks. There's going to be a seasonal pattern where the data will increase at certain points and will decrease at different points. Now, we could combine these last two, and then we get a trend and seasonal pattern. So now we're examining data within 1 year, but we're comparing them year over year. So there are certain times when it increases, but overall there is a trend where we have increasing sales over subsequent years, and we sell more in the summer and less in the winter. We're seeing both a trend and a seasonal pattern in those data. And then finally, a cyclical pattern, where we see an increase and then a drop, and then another increase and a drop. Now there is an overall trend. Maybe we're seeing a general trend upwards, but it's cyclical. It goes up and decreases, and then it recovers again. So we're seeing those alternating sequences of points above and below the trend line that occur, and they're lasting more than a year. So these are big picture items. Most of the time, that cyclical pattern is going to be due to multi-year business cycles. And those are very difficult to predict, maybe impossible to predict. If we were looking at patterns within the cruise industry over the last 5 or 10 years, we might see patterns, and then all of a sudden in March of 2020, we would see a very different pattern occur. Well, is that something you could have predicted 4, 5, 10 years ago? No. So those multi-year business cycles, especially to the degree that they relate to things that are outside of our control, make cyclical patterns very difficult to analyze or to use, or maybe even not even anything we'd want to use. So difficult, and also not something that we're going to cover in any depth. I'm just going to mention it here, but we're not going to be exploring the cyclical pattern analyses. So now we're going to go into moving averages and exponential smoothing. So that sounds like a lot, doesn't it? Moving averages, exponential smoothing. What is that all about? Well, smoothing methods, the objective is just to smooth out those random fluctuations that we see in our time series. Now these work best for short-range forecasts. They don't work well for the long-term type of forecasts. But in the short term, even or especially with daily fluctuations, a smoothing method is going to give us a much clearer picture of what's actually happening than trying to follow all the trends and trendlets and variations that occur on a daily basis among something that is changing rapidly. Moving averages. The reason we use the term moving is because every time we get a new observation, it's going to replace the oldest observation in the equation. And as a result, we're going to see changes in the averages over time as new information becomes available. We are looking for new observations. Maybe they're coming in at a daily rate. So every day we're getting new information. And we're not going to cling to information from weeks or months ago. We're going to give a limited time frame and keep moving that time frame forward, adjusting with our new information. One example where you see this is gasoline prices, because there's a lot of variability. There's a lot of quick little ups and downs with gasoline prices. So maybe we will do a 3-week moving average. Let's take information from just the last 3 weeks, and then that is going to become one data point for today. And then in the next week, we're going to make an adjustment to that. And we will use, so what you see in this pattern here, this 3-week moving average forecast, is the green line representing greater variability, which is caused by those daily fluctuations. But that smoother blue line is giving us a better prediction of where the prices are moving and how they are changing. And of course, another example that we're becoming very familiar with is with coronavirus deaths. There are great variations in the daily reports. Sometimes this has to do with reporting periods. So for instance, over the weekend, those numbers are not being reported. And then on Monday, they're aggregated again. So we're getting a report maybe on Monday, maybe it's on Tuesday. And so we get the report on Friday, and the next one that we get is on Tuesday, and that looks like a huge increase. Well, really, we're aggregating over 3 days. And so there's going to be these big changes from day to day. We don't want to just assume that on Tuesdays, there's always a increase in cases. That's not what's happening. It's an increase in reporting. So we use a 7-day rolling average to smooth out those fluctuations so that we can see where the trends really lie. It may be that we want to make some adjustments with our moving averages such that more recent data weighs more heavily in our equation. We use what is called a weighted moving average. Now the first step for this is to figure out how many data values we're actually going to use. Maybe we're using the last 3, or maybe you're using the last 5 or the last 7. But we're choosing how many data values we're going to use, and then we adjust the weight, usually based or always based on theory. The newest observations are going to get the greatest weight, and older observations are going to get less weight. A best practice here is to always make sure that your weights add up to 1 so that it makes the math easier. Let me give you an example of this. Here we have 3 weighting periods. The values that are being measured over the last 3, well, let's say 3 weeks are 17, 21, and 19, But the weights assigned to them, the one from 3 weeks ago is 1/6, from 2 weeks ago is 2/6, and the most recent is 3/6. So we're adding additional weight to the most recent number, the most recent observation, and then we're calculating our mean based upon that. So we would weight them, add them up, divide by 3 in this case, we're going to get a total of 19.33. And then finally, exponential smoothing. It's a special case of the weighted moving averages method, where we select only the weight for the most recent observation. And the values for all the other data values are computed automatically within our software, and they become smaller as the observations grow older. So in this case, we are putting the data into, let's say, Excel or some other software that we're using for our analysis, and we're assigning a value, a range in which we want this to be analyzed, and then we're getting forecasts from that. Let me show you how this might work. This is an example from Excel. The actual data are in blue, and then we're setting alpha levels at 0.1 or 0.3 or 0.8. What you see is the smaller alpha values. And again, this is something you could choose as the researcher. You could select which alpha level you want to use. Not the same as the alpha level that we've used for hypothesis testing. This is just the Greek letter that is used to say, here is the exponent that we're going to use in our exponential smoothing. So we could choose those levels, and what we see is different levels of smoothing attached with that. So at the red, we see is an alpha set at a 0.1, and the green is a 0.3, and the purple is a 0.8. So the term exponential smoothing comes from the exponential nature of the weighting scheme for the historical values. And again, it's smoothing out the pattern, giving us a better approximation. When we have a single line, or say a flat line with not a lot of variability in it, it's going to give us a better approximation of the prediction that we're making. Remember, our test, Unit 3 test, is due Sunday of this week by midnight. Study guide for that is posted, and you hopefully already have that and have been studying along with that. We will be moving into our last unit, which will be weeks 12 through 16, leading us into Thanksgiving. So we will cover 12, 13, and 14, or let me try that again. We will cover 13, 14, and 15 before Thanksgiving, and then we will not be back the week after Thanksgiving, but I will have a video posted for that. All right, so I think we're ready to wrap up. Thanks for being here. See you guys later.